So we're going to continue with the layout of the big current mirror at the bottom, the big nmos current mirror. So we select the components. Let's see. We do shift click, we select the 3 transistors, and then we go to the motion generator, and then we can see here so in this case we have a rather large number of instances that we have to lay out. And I mean, we can do exactly the same as we did before, try to find a way to do it in 2 rows, but in this particular case the aspect ratio is not very good, so let's add another. So then we have 3, it is much better, and when we put these components close together, the aspect ratio probably is going to improve. Now the question is what to do with this. We have to find a way to put this in a common centroid and distribute it very nicely. So the critical transistor for us, it is the C, it is the diode connected transistor, that it is bringing basically the reference for the other transistors in the current mirror. So these have to be in the center, and all the other transistors have to be close by these transistors, so that there is a good matching. And this is a good example of what happens when we have very large current mirrors or components that have to be matched with very large ratios. So there will not be really possible to put instances very close to the reference. So we will have to compromise. So one alternative that I have here is the following. It is common centroid. I have placed the diode connected transistor exactly in the middle of the common centroid. The tail current, that is the transistor A, I put it close to the reference transistor, the diode connected, and then I put all the other instances for the output current mirror around, that is transistor B. So we have 3 rows here. Now we can see that we cannot use, I mean, if we want to have to follow the complete rules for matching, we can not only put dummies on the right and on the left, because the transistor in the middle will not be facing the same process as the transistor that are on the top and bottom borders. So I will have to add dummies on all sides, and yeah, I can do the following. So I can add dummies on the top, on the bottom, and on the sides. And these dummies do not have to have exactly the same dimensions as the transistors that are inside. So we can make in particular the ones that are on the top and the bottom, we can change the width and then just keep the length. So we can do like that. So we are going to keep this structure here. So we go back. We are going to add this. Let's going to delete this one and add the dummies. So we need to add 6 dummies. Let's see, multiplier 6, apply, and these 6 dummies we're going to connect to ground. So we're going to short all these dummies to ground. And we are going to keep the same width in this case for the dummies that are going to be on the borders. So these will be these dummies, the ones on the border, the Ds. Then I need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15. See? These are 14, 28. We need 28 dummies for the bottom and the top of the bottom. 28, so I can copy this one. These are also going to be grounded, and that will be multiplier 28. For these ones I can save some space. I really don't need to make it so large, so we can make it a little bit smaller, for instance 2 micrometer by 2, even we can go to 1, but let's keep it like 2. Okay, we have it like that, 28, and then we are settled. We select the transistor, and I select my dummies here, and then I go here, and then I have all the devices that I have to connect, and then I customize, I select 3 rows, I delete this placement, and then I copy the placement that I already decided, apply, and okay, we have that our devices have been placed and are really to be connected. So I'm going to save as it is right now.